This is the most powerful electrical force on Earth. Around the world, lightning strikes more than 8 million times every day, 6 times hotter than the surface of the sun, releasing as much as 1 gigajoule of energy. It defies the laws of nature. Although it is known to be dangerous if you are in the wrong place at the wrong time, it is also the source for life. The combination of air, water, and electricity creates the ideal circumstances for plants to grow. In a thunderstorm, ambient air is activated by plasma that is formed by lightning. This activated air is brought into contact with rainwater, which causes the reactive oxygen and nitrogen to dissolve into the water. This creates plasma-activated rainwater with unique temporary cleaning abilities that finally settles into stable fixated nitrogen.
Plasma-activated water, this is water which is treated by plasma, typically in the air. After treatment by plasma, that became this water rich of many reactive oxygen and chemical nitrogen species, which possess quite long chemical activity, and they have even the biocidal effects. The beauty and the interesting part of the plasma-activated water is that we can use it remotely after for some application, including agriculture one, for treatment of seeds, plants, using as a fertilizer, etc. We are dealing with the chemical characterization of the plasma-activated water prepared by different plasma sources, because this is one of the very important tasks. We need to understand how to prepare the plasma-activated water.
This is, for example, a detection of nitrites and nitrates in plasma-activated water by means of ion chromatography. Here you can see the chromatograph of the plasma-activated water, where we can see the peaks for nitrite and nitrate in the ion chromatography procedure. In our plasma-activated water, which is made by the electric barrier discharge above the water surface, we can generate quite a high concentration of both nitrites and nitrates, as well as hydrogen peroxide. For these concentrations, we also measure quite a low pH value of about 2 or 2.5. So it means that this liquid is acidic.
Properties of plasma-activated water can change very significantly depending on the plasma source, gas, and also the contact of plasma with water. And in our group we are studying generation of plasma-activated water and possible applications in medical research and agriculture. And in our research we focus, for example, on production of plasma-activated water by using discharges which are able to transform water from bulk to micro droplets, and this aerosol is then in very good contact in plasma, and thus we are able to produce plasma-activated water very efficiently.
And we also analyze, let's say, concentration of antioxidant enzymes, just to see whether the plasma-activated water can cause some stress to the plants, which is very important. And we also not analyze even leaves, but generally from the seedlings, both parts, like roots and also the, as they said, above ground part, that means usually leaves and then the rest. And we also analyzed, let's say, the roots that we cut them, and we also did some measurement with fluorescent measurement just to see, for instance, how the walls of the cell walls lignify. That means how they harden in time, whether, let's say, plasma activated water supported the growth of the plant, because many times the properties of the plants which are affected by plasma activated water is not really visible. Like if you consider the plants, you see they are a little bit bigger but not that much, but usually on macroscopically. But if you go microscopically, then you see many of the parameters improve, which cannot be seen by a naked eye.
You can imagine that if you have a needle, medical needle, and you provide a water through this needle very slowly, for example 1 milliliter per minute, then there appear droplets which fall down from the needle, and if you apply electric field, so you apply high voltage on this needle, the electric field changes the properties of surface tension of the water, and as a result, as you increase the voltage, the droplets become smaller and smaller, and at certain point the production of so-called Taylor cone at the top of the needle, at the nozzle will emerge, and from this Taylor cone microdroplets will start to drip off. And these microdroplets can have diameter of several tens of micrometers. Then at certain voltage there will be not only spray but also coronal discharge appears. In our laboratory we are able to make a diagnostic of gas phase production species. For this purpose we are using either infrared absorption spectroscopy or UV absorption spectroscopy for species like NO, NO2, ozone in a gas phase, or nitrous acid, for example, in a gas phase. In a liquid phase we use colorimetric methods usually.
Well, basically, when we let the cold plasma or non-thermal plasma, which is a gas plasma produced by strong electric field, without very much heating the gas to keep the temperature low, and we let it interact with liquids, for example water, in different ways. There are different setups that do it. We obtain this so-called plasma activated or plasma treated water. And then depending on the different types of plasma, gas, environments, conditions, we get different chemical activation in the water, which can be temporary or for short term, but also long term. And such plasma activated water typically shows some antibacterial or antimicrobial properties, so it can be used to disinfect surfaces, medical instruments, but also living wounds. It may have some other biorelevant properties. For example, it can be used to selectively treat cancer cells for a future cancer or potential future cancer treatment. But also, this plasma activated water can be very much enriched of nitrogen species, from nitrogen from the atmosphere, making nitrites and especially nitrates in the water, so it can serve as a fertilizer for agriculture. So there is this antibacterial action on one hand, and there is this nitrogen-rich fertilizer on the other hand, and we can have also kind of both aspects combined in one type of plasma activated water, which seems to be very beneficial to promote the plant growth, for example. And we study in fundamental way, experimentally, these transport processes, for example, of hydrogen peroxide, ozone, and then different nitrogen species. And what we found out is that, for example, ozone, which is badly soluble, doesn't dissolve well, so it really helps if we make small microdroplets or aerosol of water. So that facilitates the transport. On the other hand, if we have hydrogen peroxide, it's very well soluble. It's so well soluble that often the limitation factor is the gas phase concentration. So we practically the water will take everything which is present in the gas phase as hydrogen peroxide will go into the water. And then these nitrogen species, the solvation of different types of nitrogen species typically leads to nitrites, NO2 minus ions, contributed by NO, NO2, but especially HNO2, which is a dominant source of nitrites. So then we get all these species in the liquid, and hydrogen peroxide and nitrite are really important in the sense of antibacterial action of the plasma activated water, because they can produce these peroxynitrites, which are really active antibacterial components. And by changing different parameters in the plasma, we can tune the composition and parameters and properties of the plasma activated water depending on the application. But the applications are different. There are several types. One of them is treating the seeds, agricultural seeds, to promote their germination. And indeed, soaking the seeds in plasma activated water facilitates or enhances the germination of the seed. But it's not just that. Then the plant growth is somehow enhanced as well, especially the early stage of the plant growth, so the seedling and the first days and weeks of the plant growth are much improved and promoted, so the plants grow faster, they grow bigger. And even more importantly, from the point of view of economical benefit, the plants which are somehow treated with plasma activated water, either as seeds or already as plants which grow, they seem, based on several researches of our group but also different people's group, they can make more product, more agricultural yield. They make more seeds or more fruit, more products. So far in our group, we have tested more or less on a laboratory or small field scale. So doing really well-controlled laboratory plant experiments in collaboration with our partners of plant physiology, but also small-scale field experiments in outdoor conditions, and we are testing that, and repeatedly several years we have been testing those. So we can reduce the use of fossil fuels, carbon dioxide emissions by fixing nitrogen into the water with the help of the plasma from renewable electricity sources, which can be small sources distributed in farms. So with no need of huge plants like the current technology of ammonia production by Haber-Bosch technology.
I think that will be the energy cost. It will be for the market always important issue how much that cost.
And the most difficult thing is we usually work in a laboratory scale. That means we usually generate a very low amount of plasma activated water per unit of time. If you want to go to a field, people ask you to generate for the same time much higher volume of the water, which is very difficult.
A major challenge for me is the upscaling to reach reasonable production rates of this plasma activated water.
Safety issues, possible toxicity effects in plasma activated water.
The other challenge is to understand these mechanisms, to really be able to tune the plasma activated properties from one tip or specific for application, if we want to treat only seeds or we want to promote the plant growth or to make bigger yield.
So this is a device which is combining two phenomena together, cavitation or hydrodynamic cavitation and cold plasma discharge. The device is seen here. This is, let's say, a demonstration unit for 1.3 cubic meters per hour treatment of the water. It was awarded by several awards here in the Czech Republic because of its uniqueness, because of the large amount of water that we can treat. So we are starting in this unit with 1 cubic. So the power consumption of this device is 1 kilowatt hour per 1 cubic meter of the treated water. And this device can work in 2 modes. The one we call the direct mode. It means that the polluted water is going directly through this, which is not probably of interest for this project. And the other is that we can prepare so-called plasma activated water. It means after one or several treatments within this device, we produce a water which has some content of hydrogen peroxide. And this water can then be used, for example, for some flushing of contaminated surfaces in agriculture. The scaling was surprisingly simple and without any problems, I think, to, let's say, surprise of all involved people.
This device combines 2 unique technologies: cavitation, which means we are producing a low pressure gaseous environment inside the liquid, in which we can easily turn on the discharge.
What we sell is machines that can produce plasma activated water on site at customer's location. Our machines can produce 30 moles of nitrate per hour, and those are 15 kilowatt machines. And one machine can provide, depending on the type of crop, a half a hectare or up to 2 or 3 hectares of cultivation with nitrogen fertilizer. The farmer needs about, depending on the crop type, 10 millimoles per liter. So we provide it with a fertilizer solution that has 10 times or 20 times that much nitrate in it. But we make sure that there is no nitrate in it because the growers don't want that. They see a nitrate as toxic. And indeed, in higher concentrations, it can be toxic for plants. Specifically, if you grow the crops on hydroponics, then you only have water with nutrients, and then those components can interfere. If you grow on soil, then the soil has a buffering effect, and that can then the effect is not that large. When we look at the other application, then we do want the other species. Then we do want hydrogen peroxide. We do want some nitrate. If you want to disinfect with plasma activated water, we have different machines for doing that than only pure for nitrogen fixation.
So it's basically based or driven by the application, by what we want to achieve, what is the desired effect. Then you can tune the process to make either peroxide, nitride, or nitrate, just nitrogen fixation for fertilizer. Yeah, that's actually a big advantage of plasma technology, that it can be relatively easily scaled to small scales and even large scales, but also can be tuned to different purposes, different objectives.
Yeah, that's correct. Yeah. We can currently not compete with the traditional synthetic Haber-Bosch process for nitrogen fertilizers. So we are more expensive. But if you look, for instance, to the organic market of growing vegetables and growing food, organic fertilizer are much more expensive than the synthetic fertilizer. We are competitive in the market of organic fertilizers. So that offers an opportunity for us and a challenge at the same time. But as you probably know, the industry which is producing ammonia, the Haber-Bosch industry, wants to shift to a carbon-free production of ammonia, and then they want to use hydrogen for that, the so-called green Haber-Bosch process. If you compare our technology with green Haber-Bosch, then we are practically the same, and within 1 or 2 years we will surpass them, that energy efficiency.
So this is based on this publication, Cerca. So in terms of energy consumptions in megajoules per mole, and non-thermal plasma is the blue one here, and the theoretical limit is somewhere down here, which converts to gigajoule per ton of nitrogen, something like I think this is like something like 10.
We are at the beginning because the technology is new, no regulations, and we need to find out where we stay, where is the position. A lot of people around the world, not all of them, but a lot of them already understood that climate change topic is not something which we should ignore. So this topic is really, really in focus, and I don't think that this topic would go away in a few weeks, few months, or maybe in a few years. Because we need to find a way together, so all humans, to find new solutions, innovations, maybe to try new ways. Because we are at the beginning, you asked me about the future. Let's see what it brings, because there are a lot of possibilities. So as I already said, there are medical applications with plasma activated water. There are wound-healing topics. Disinfection is a huge topic around the world, especially after COVID or during the COVID. But on the other one side, there are also topics with wastewater. So this topic still exists since a long time, and there is no way to say, okay, this topic was going away or whatever. So it still exists.
One day, sooner or later, plasma-based agriculture will be one of the main agriculture worldwide, and will progressively push away the current fossil fuel-based Haber-Bosch technology for ammonium nitrate sulfate production as artificial or chemical fertilizers.